So the optimal plan involves picking the best indexes and join orders. As the number of tables increases, the number of permutations the optimizer has to evaluate increases factorially. Think about that for a minute. What that's saying is that if I have one table, I've got one join order. Two tables, I have two possible join orders. Three tables, I have 6 possible join orders. 4 tables, I have 24 possible join orders. So with each additional table, the number of join orders goes absolutely nuts. As a result, when you have the situation where you have a 50-plus table join, and I'm not making that one up either. I had that one happen at a client site in South Florida. When those types of things pop up, you have to be aware that one of your problems is that the optimizer needs some amount of time, and this is going to be measured in potentially hundreds of milliseconds, to evaluate what's a likely best join order. Now, sometimes, and it is unusual to have to do so, but sometimes you do need to fool the optimizer by breaking up the query into parts. Sometimes we do that by using derived queries or derived result sets. Derived tables. Sometimes we do that by breaking these things up into temp tables and or memory-only tables. Do be aware that sometimes temp tables are faster and sometimes memory-only tables are faster, and a lot of that has to do with the size of the table that you're using, the amount of memory that you've got, and how fast your tempdb storage is. Note that some permutations are so unlikely that the optimizer is not going to be able to evaluate them. For example, a contation product followed by a filter is not likely to bring things back any faster, and as a result, the server won't bother. Now, keep in mind also that the way we write the join is going to have some control over the possible join orders that we've got. In this example, this is that AB example. We have a table called authors. We are joining it to titles, but we have many authors writing many titles, and many titles can be written by many authors, so we've got that junction table, that title-author table, that sits in the middle. What we have are 2 possible join orders. We can go author, title-author, titles, or titles, title-author, authors. This is being driven in part by the join condition, where we're joining from authors to title-author on AUID, and then titles to titles on the title ID. Keep in mind that the way these things are indexed is going to drive the performance. A couple of quick tips for the optimizer. We used to have about 3 pages of these, but over the course of the last 15 years, we first wrote this, longer than that, wow. We first wrote this class back around 1995 for, I think it was SQL Server 6.5 or SQL Server 7. I don't remember which one was current then. But every time a new release comes out, the optimizer learns new tricks, which makes some of our tips a little bit out of date. However, this one is still true, and it's interesting in that thinking through this also helps us identify how the optimizer is going to work. So here we're joining from table A to table B. If we write that as we have on the top, A join from A join B on A.key is equal to B.key, that is a pretty standard join. Now we look at the where clause, where A.key is equal to ABC. Here's the thing. Because I have a where clause which gives me a search argument on table A, that means I'm going to be able to restrict the rows in table A, and once I've restricted the rows from table A, only join to table B for the appropriate rows from table A. But here's the catch. If A.key is equal to ABC and A.key is equal to B.key, we also identify that in order for this join to work, B.key also has to be equal to ABC. As a result, adding that additional search argument means that we are giving the optimizer the additional possibility of joining from B to A rather than just from A to B, and using a matching index for the matching value on B. It may turn out that this is faster. In fact, what we may also find is that it may use both, and it may subsequently do a merge join on the 2 columns, which would be even faster. So, moral of the story here is be aware of how the search arguments are written, be aware of the possible join orders, and help the optimizer where you can.